Good morning. Today we're going to work with a review of our right triangles and several things that we have covered in Algebra 1 and then studied again in geometry. Reviewing Pythagorean's theorem, you can look at the notes of when to use it, the terminology of, we call each side the legs that form the right angles. The side opposite the right angle is called the hypotenuse. Try to get away from just saying a squared plus b squared equals c squared and use leg squared plus leg squared equals hypotenuse, because we might change around where a, b, and c are located. You can look at the examples. You can see how we are setting up the equation. Just remember that the hypotenuse must go on the side of the equal sign all by itself. The first example, you can see that it's straightforward on how to use Pythagorean's theorem. The second example, just remember that you must simplify all radicals. So when you get down to this x squared equals 52, take the square root of 52, simplify that by breaking it into square root of 4 times square root of 13, and simplifies to 2 radical 13. You can look at the other two examples. They should follow pretty simple. Again, you're going to see that you're going to work with a lot with radicals. In the second type is a special triangle of a 30, 60, 90. You have your terminology, and we call the shorter leg, longer leg, and hypotenuse. Just make sure that you know the shorter leg is always opposite 30, longer leg is always opposite 60 degrees. Two rules. You need to have these memorized. Hypotenuse is a short leg times 2. The longer leg is a short leg times square root of 3. Now you can be able to look and see which side are you given. In the first example, you are given the hypotenuse. So always find the short leg first. And then you can be able to see that by using your rules. In the second one, you were given the short leg. The third example, you were given the hypotenuse again, but it was as a radical. And again, you're going to have to rationalize denominators. You're going to have to be able to multiply with radicals. Just remember, you can never leave a radical in the bottom of a fraction. You can follow through with all of those examples that are shown. If you have questions, make sure you email me today so that we can talk about that. Now let's move on to the next type. In the 45, 45, 90 triangle, we again have the legs as the sides forming the right angle. Hypotenuse is still the side opposite the right angle. And we have one rule in this. It is the hypotenuse is equal to the leg times square root of 2. You got to keep these straight between the rules for the 30, 60, 90 and the rules for the 45, 45, 90. Again, you can see how this is set up with the examples. And whether you're given a leg, you just have to multiply it by the square root of 2. If you're given a hypotenuse, you'll divide by the square root of 2. And once again, simplify your radicals. And also, if you have a radical on the bottom, like in example 3, you do need to rationalize it, get rid of that radical. The bottom section is the right triangle trig, where we don't have a special angle of 30, 45, or 60, so we will use SOHCAHTOA. And as long as you know how to spell the word SOHCAHTOA, then you know your rules. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. You can look at the examples. You will be given two sides. When you are given, you're given an angle and one side, you have to find the two sides. So looking at that, decide which two sides are you given. Are you given adjacent, opposite, or hypotenuse? Then use the correct trig word to be able to write your equation. And then when you use your calculator, make sure that you are in degree mode and you can type these in to be able to come up with those answers. Again, if you have any questions, make sure you email me. I'll be happy to help you. Have a great day. Thanks.